Picture this. You step out of your habitat onto a frozen alien landscape. The sun, it's just a really bright star in an endless black sky. But hanging right there, dominating your view, are the swirling, beautiful bands of a gas giant. Now, this isn't just some science fiction movie. This is a real detailed blueprint for humanity's next great expansion into the cosmos.
And, just look at this. This isn't a fantasy painting. It's a tangible glimpse into what our multi-planetary future could actually look like. We're talking about building sustainable outposts on moons orbiting planets hundreds of millions of kilometers from home. This is the high frontier, and believe it or not, the plan to harvest it is already being mapped out.
So why? Why go through all this trouble? Well, it boils down to this single, powerful idea. The stakes couldn't be higher. The outer solar system has, for all intents and purposes, endless supplies of water, organic compounds, and precious metals. Enough to end resource scarcity back on Earth. Forever.
You know, for decades, we've all been focused on the Moon and Mars, and that's great, but you have to think of them as just the training grounds. What we're talking about today is what comes next, Tiers 3 and 4. This is the true leap, the moment humanity finally ventures beyond our little cosmic backyard and into the vast, unbelievably resource-rich expanse of the outer solar system.
And the potential payoff? It's just immense. I mean, look at these estimates. A full 40% of the harvest could be helium-3, which is a key ingredient for clean fusion energy back home. Another 30% is water ice. And think about that. Water isn't just for drinking. You crack it open, and it's breathable oxygen, and it's rocket fuel. This is the stuff that will literally power our entire expansion.
Okay, so how do you even begin to tackle something this huge? Well, you break it down into two major frontiers. First, you've got Tier 3, the gateway, which covers Jupiter and Saturn. Think of it like a cosmic gold rush, the Wild West. Then there's Tier 4, the deep freeze. That's everything beyond. That's the long haul, a journey into automated, remote outposts. We're going to start at the gateway, the Jovian system.
So, our first port of call is the Jovian system. Jupiter is, without a doubt, the energy hub of the outer solar system. Its massive gravity well is perfect for slingshotting ships all across the system. But, and it's a big but, it comes with a lethal catch: absolutely intense and deadly radiation. And this is the critical trade-off you have to understand. Jupiter's gravity gives you this huge advantage, like a free energy boost, to fling ships where they need to go. The hazard? Its magnetic radiation is like living inside a constant, powerful solar storm, so the architecture, the way we build things there, has to be incredibly clever.
And this right here is a perfect illustration of that cleverness. On the left, you've got Callisto. It's kind of the ugly duckling of the Galilean moons, but its distance makes it the safest place to be. It has the lowest radiation, so it's the perfect spot for a base camp with surface domes. But then on the right, you have Europa, the high-risk, high-reward science lab. Its surface is just getting blasted, so we'd have to build submarine-like bases, tunneling deep into the ice to explore that vast, hidden ocean underneath.
The final piece of our Jovian network is Ganymede, the absolute industrial giant of the system. This moon is bigger than the planet Mercury. And get this, it has its own magnetic field, which gives it natural radiation shielding. So its role is clear. Heavy industry, powered by nuclear reactors, with these massive centrifuges creating spin gravity to help humans combat the long-term effects of living in a low-G environment.
All right, so after leaving the radiation-soaked world of Jupiter, we arrive at the Saturnian system. It's a lot calmer here, it's colder, and it's home to this incredible, diverse archipelago of moons that could become the true economic engine of the entire outer system.
People have actually called Saturn's system the Persian Gulf of space. And honestly, it's a perfect analogy. Just like the Persian Gulf on Earth exports oil, Saturn's moons are ideally positioned to mine and export helium-3, water ice, and other vital resources to everywhere else. And the bonus? The radiation levels are way lower, making everything just a whole lot easier.
Now, the absolute star of this system has got to be Titan. It's often described as a cold alien Venice, and for good reason. It has a thick nitrogen atmosphere, even denser than Earth, and these vast, dark lakes of liquid methane. This environment lets you dream up some incredible architecture, like floating cities right on those methane lakes, harvesting fuel and complex organics for making things like plastics.
And here's a wild little fact for you about Titan. It actually rains there, but the rain is liquid methane, which means, and I love this, the rain is literally fireproof. So yeah, you might still want an umbrella to stay dry, but you definitely won't need a fire extinguisher.
Next up, we have Enceladus, also known as the Fountain of Youth. This little moon is just remarkable. It literally shoots geysers of water, organics, and life's building blocks directly into space from its south pole. This makes it the ultimate refueling station. Seriously, ships can just fly through the plumes and collect everything they need without ever having to land or drill. It's like a cosmic drive-through.
And the rest of Saturn's moons, places like Rhea and the Apotus, they form the system's blue-collar engine. These are the workhorses, the mining outposts, digging out water ice and silicates from deep beneath the surface. You can just imagine these networks of buried habitats, all connected by a super-sophisticated maglev rail system linking all these distant work camps together. Okay, buckle up. Now we take the final leap into Tier 4, the frozen frontier. This is the long haul. We're talking about venturing to the very edge of the solar system where sunlight is just a faint whisper. These outposts would be for automated pioneers at first, with humans maybe following centuries later.
Out in the Uranus system, on moons like Titania, you might build these incredibly quiet astronomy outposts, beautiful domes carved right out of the ice. But then you go even farther out, to Neptune's moon, Triton, the backward moon, and it's a whole different story. Its weird orbit creates intense tidal heating, which could actually power geothermal bases, harvesting nitrogen from its icy geysers.
And finally, we reach the Kuiper belt, the wilderness at the edge of the map. Outposts on icy bodies like Pluto and Charon would serve as way stations, getting us ready for future interstellar travel. We're talking about deep cryogenic storage, with underground habitats and fully automated AI-managed farms that support the occasional human crew.
So we have this absolutely incredible vision, this blueprint for a multi-generational legacy that stretches across the entire solar system. But how in the world do we actually build it? I mean, the engineering challenges are just immense, but the solutions are every bit as ingenious.
You see, for every extreme challenge you can think of in deep space, there's a clever engineering solution. You've got deadly radiation? No problem. We build underground or use thick walls of water for shielding. The crushing effects of low gravity? We create our own artificial gravity with centrifuges. The bone-chilling cold? We use nuclear thermal heating. And for the immense isolation, we learn to live off the land using something called in situ resource utilization, or ISRU.
And at the end of the day, that's what this is all about. These places aren't just fascinating dots on a map to visit. From the methane shores of Titan to the deep freeze isolation of Sedna, this entire architectural plan is really a blueprint for the long-term survival and prosperity of the human species. So how do we get there from here? Well, it really seems to come down to three things. We absolutely must invest in the technology to make it all possible. We have to foster international cooperation to make sure we do it peacefully. And above all, we have to keep dreaming big. Because the truth is, the architecture of our future in space isn't something that's just for our great-great-grandchildren to figure out. It starts right now. It starts with these plans, with these ideas. So the only real question left for us to answer is, what are we going to build?